Welcome to Almost Here, Round the Corner Future Technology podcasts with Richard Jacobs. Future technologies poised to transform our lives for better or worse are the focus of this podcast. Almost here means these technologies are now here and starting to be used, or just around the corner, from Bitcoin to artificial intelligence, 3D printing, blockchain, virtual reality, and more. Coming to Dallas, Texas, September 14th, 15th, and 16th, 2018, the Blockchain and Future Tech Expo. This is going to be a gigantic conference of over 5,000 people. We're going to be talking about blockchain and its applications. We're going to be talking about quantum computing, cybersecurity, artificial intelligence, and several other future technologies that are poised to and actually changing our lives as we speak. Here's why you should attend. As you may know, early adopters are the ones that investigated and profited from things like the gold rush in the 1800s, from the dot-com boom in the 1990s, from the internet boom in 2005, from the smartphone explosion in 2007, from the real estate boom that ended in 2008, and of course, from the Bitcoin boom that started in 2012. Early adopters act now. They don't wait till later. They go out west first. In their covered wagons, they find the biggest gold nuggets. If you consider yourself an early adopter and you want to find the biggest nuggets, then you owe it to yourself to attend this upcoming conference. Blockchain is going to affect how we control and store our medical data, how we send money around the world, how we bank, and more. But artificial intelligence, quantum computing, and cybersecurity will play a pivotal role in our lives as well. And that's why our next event, September 14th to the 16th at the Dallas Convention Center, is going to have not only 5,000 plus attendees, but will showcase blockchain, AI, cybersecurity, quantum computing, and more. You want to get in on the coming gold rush of future tech and opportunity as an early adopter. Don't be left out. To register, go to bftexpo.com. That's blockchainfuturetechexpo.com. Thank you.
Hello and welcome to Future Tech Podcast. This is your host, Juliette Lamar, and we have with us on the line Laurent Pambaguian, and he is with the European Space Agency, ESA, and we're very excited to have him on today. Welcome.
Thank you very much, Juliette.
So, Laurent, why don't you give us a little bit of an overview about what you do at the European Space Agency?
Well, my contribution to the European Space Agency, to ESA, is to look at the very basic first elements of a mission or of a spacecraft or of a launcher. It means the materials and the processes that are used to transform these materials into space hardware and to ensure that the material will not fail during the overall space mission. This is my daily work.
Wow, so very, very important. If your job fails, the entire mission fails.
Yeah, if any person's jobs fail, the mission can fail. So I am important just like all the others, meaning not so significant.
It truly is a team, and you have to really invoke a lot of trust with your fellow team members.
Yeah, indeed. But when I see the people who are surrounding me, I can tell you that at ESA, we have a tremendous knowledge, a tremendous expertise with respect to space missions. So I trust, I would say, all my colleagues because they know things that I don't know, and they trust me as well, so it's fine.
And what are some of the space missions that you've gone on but that you've been a participant in that you've been very proud of?
I am very well. This is again a question where I do not contribute directly to the missions because we are doing more the development of the materials. But if you want to get an idea about a mission that has been extremely challenging, you have a mission that is named Herschel, for which it has been necessary to develop a technology to make ceramic mirrors. So you know that ceramic is like what you have into your cupboard, plates, etc. So if you touch them and you drop them, they break. Mm-hmm. And to put a ceramic mirror into a space mission took more than 20 years of technology development for materials. Okay,
wow.
and it requires developing a lot of different technologies for making the right composition of the ceramic at the beginning, to put it into a shape, to bond the different elements together, to go for grinding, to polishing, to surface coating, etc., etc. But when you look at the final result, it's quite amazing, because the mirror weighted 300 kilograms, and any other alternative in terms of technology was with 1.5 tons.
Wow,
and,
significant difference.
This is a tremendous difference, and thanks to this technological development on materials and processes, the mission was feasible, while with the other technologies it was not feasible, or the performances of the instrument would not have been as good as what we achieved. So this is the kind of thing that we are dealing with respect to the material and processes.
Absolutely. And besides the weight factor, why else was ceramic such a challenge to work with and so rewarding?
Well, the ceramics are materials that are a bit special. First, they break very easily. Second, they are extremely hard. So if you want to polish a ceramic, it is difficult. It takes time. They are quite inert, meaning that if you want to put a coating, and we need to put a coating, it is extremely difficult, because the coating will not adhere. Okay? And beside, the ceramics that we have been using is extremely stiff, so this allows to reduce the weight, and extremely good thermal conductor. It means that we can have the same temperature everywhere onto the antenna, meaning that the antenna will not deform due to change of temperature. And it has also a so-called CTE meaning coefficient of thermal expansion, that correspond to the way it will expand with temperature or shrink with decreasing the temperature, that is very small. So all these reasons were leading us to select ceramic as the ideal material for this type of activity, for this type of development. And we have been proven right.
What are some of the upcoming missions that you are excited to work on, and some of the upcoming challenges that you are excited to solve?
Well, as I stated, I am not working on the spacecraft themselves. I'm working on the technology that will enable to make a spacecraft. So there is another.
Exactly.
Yeah, there is another one that will be launched within the next few years. That is the Solar Orbiter mission. Okay, the Solar Orbiter mission is a mission where we'll go quite close to the sun. And for this, we need to put in front of the sun a thermal shield. So just like to protect all the instruments, we need to put some foil that will resist to, I believe, 600 Celsius or 450 Celsius, but a very high temperature considering what we are doing generally in space. And when we started the project, to make this kind of thermal shield that would sustain this amount of temperature for long duration, and that would not induce any particles going into the instrument, was considered more or less as impossible. At the same time, I was working on a low technology readiness level system where we asked a small Irish company to look at capabilities to put black coating on titanium. And they were using a very elegant process that is the same as the process that was used by the Neanderthal people to paint into their caves. And it was the same type of material, meaning that it was charred bones that were used and that were projected onto the surface of titanium. And with this technology that is initially extremely simple, we increased very steeply the TRL, so the technology readiness level, meaning the capability to deposit this type of coating on top of titanium within the next 5 years. And we started from scratch to the baseline to have this front shield protected by these charred bones and to enable the mission again. And so this spacecraft will be launched, I believe, in 2 years. And the way it can be launched is because we have been developing this technology to coat titanium with black coating.
Wow. You're working with a lot of different materials and the combination of those materials. Are you also working in creating entirely new materials that can be used, either here on Earth and also in the space program?
Yes, somehow. Meaning that we at ESA, we have been starting to look at 3D printing technologies in the perspective of establishing a moon village. And therefore, what we have done a few years ago, and it was back in 2012, we have been pushing for a technology to find out if it was feasible to take the lunar regolith, so it means that the soil that you find on the moon surface, the sand of the moon surface, and to transform it into a solid using 3D printing technology. And
wow.
So what we have done is we had a consortium and we made the design of what should a lunar base look like, and we looked at the material, the processing to change this material that is a powder, and to transform it into a solid. And we demonstrated that even taking into consideration the vacuum that you have on the moon, the process can be realized. So it means that you can transform your sand into a kind of cement. And we have a 1.5 ton demonstrator that has been printed to show that size was not really an issue. Okay, and when we do this, demonstrating that it is possible to take the local material on the moon to print a moon base, suddenly it changed totally the way we have to design a manned mission to the moon. Instead of bringing the habitat that is fully furnished, we say, okay, we bring a system that will build the habitat at destination, and then it will be possible to have a larger habitat. It will be possible probably to maintain and to repair the habitat, to add some more habitat, etc., etc. And therefore, through these material and processes, we can enable new type of missions.
Absolutely. That's a very large step forward. If you can, once on a different planet, you can start building and not have to bring everything with you, and cost effective as well.
Yes, the cost effectiveness. I mean, this is not my favorite type of numbers, but a rough estimate for bringing 1 kilogram of payload on the moon would be 1 million. Take it as dollars or euro as you wish, but this is more or less the price. So any kilogram that we save is something.
Wow. And how did you, give us a little bit about your background? How did you get involved with making these type of materials, and how did you get involved with ESA?
Well, first, my education. I have a PhD. Mm-hmm. I have a PhD on the behavior of interfaces. So it's interfaces is something that does not really exist. So if you want to paint a wall, the interface is between the paint and the wall. So it has no thickness, it has no existence. It has, but it is driving, in fact, the adherence of the paint on the wall. It is driving all the properties that you will have with respect to resistance to corrosion or this kind of thing. So it's a very interesting and very versatile type of problem that we find in interfaces. And for the last 25 years, I work on the problem of interfaces. And if you think about anything, you have interfaces everywhere. So into your social life, into when you are contacting, when you are sitting into your car, you have plenty of interfaces with your car. So it's bringing a lot of problems, and it is then extremely interesting to look at interfaces from all the point of view. This is my background, and later on, as it was not complicated enough, I made a postdoc to make some solid lubricant materials, meaning that I become somehow a tribologist, so the science of wear and gliding, where in fact it is a kind of interface that is moving and it generates something between the two surfaces that you are rubbing one against the other. So this is my background. How I arrived at ESA. My PhD was dealing with materials that were foreseen for space, and my postdoc was also for materials that were developed for space use. So it was natural somehow to end up at ESA.
Yeah, exactly, because this is a very hard problem that needs to be solved. And how do you feel that the materials that you are creating and the different material compounds that you're putting together, do you find that those can also help here on Earth in certain ways?
It can help us on Earth. First of all, it can help us into, for instance, looking at if you are able to put something in space, it means that you have a reliability that is fantastic, that you have a process control that is fantastic. So you can really design much better than for any other industry, and you can guarantee somehow a lifetime for your product. It has a cost, so the cost balance is not the same for all the industries, but it is something that is extremely useful. Second, and this is also interesting, it's in space, the amount of resources that we have is always extremely limited. On a spacecraft, all the power is coming from the solar panel, and you cannot extend the solar panel as you wish. So you have to size all your mission based on the size of the solar panels. And so to look at a different perspective from Earth, saying that you are saving resources everywhere and still you enable something that is amazing in terms of results, is something that can be also transferred back to Earth, and we can use this kind of knowledge.
Wow. It's got to be, every day at work for you has got to be something different. It must be like a puzzle every time you arrive.
Yeah, I mean, I have been developing expertise mainly on additive manufacturing that the public calls normally 3D printing, okay? And this is a technology that is 25 years old. And as such, what we do every day is to scratch our heads, because when you use conventional technology like machining, we have 200 or 300 years of knowledge behind us. We know very well how to design. We know very well what are the capabilities of the machining tool, what are the limitations of the machining tool. We have a set of standards that is extremely broad, extremely large. But when we deal with additive manufacturing, we have to ask ourselves, am I on the right path every day? And this is something that makes the job even more interesting.
Absolutely. Now, with 3D printing, you said that technology has been around for 25 years?
The 3D printing is a bit older, but it was called before rapid prototyping, meaning that the part that was produced was only for decoration. It was not functional. But when you look at additive manufacturing or 3D printing, now what we do is we 3D print polymers, but we also 3D print metals. We also 3D print ceramics. We also 3D print regolith. And when we make a part of metal, for instance, we can make this part that will be much lighter, much more efficient than with conventional processes. And today, the European space industries are developing brackets and other elements that they mount on their satellite, and they are launched. So we have suddenly mass savings that can be in the range of 40, 50, 60, 70%. And looking at the cost of launching on low Earth orbit, that is, let's say, something like between 20K and 50K per kilo, it's something that is also quite interesting.
I know it's incredible. And what other avenues do you see this industry going into with the printing and with creating new materials?
This is something that we have difficulties to realize because we can see what we are doing today. We can see that during the last 15 years we have been learning from our mistakes, and we have made plenty of mistakes. So we have been learning a lot, and we know a lot. But still, we don't know how broad this industry will become. What we see is that you are making made-to-measure parts. So we can imagine that it will be for all the different publics. You will have your shoes with heels that will be made for you, specially. Or you can imagine that each of the airplane company will have brackets that will be made especially for them. So the number of possibilities is just tremendous. And if we look at this, we can also say, well, this can be also a new market for spare parts. Instead of having many spare parts that will be placed into a place, we can have the digital file of the different parts that we may need one day or another. And whenever there is a customer coming with his car and one part that is broken, we can print it on demand. So it can change the way we are looking at spare parts. It means that we can change also the place where the things are manufactured. And we can also save a lot of let's say, transport, because into your manufacturing facility, you will have mainly powder of the materials that you need to process, machines that will be process the material, and some system to finish the part and to make it to the final tolerances. And also the time. Today, if you want to transport from China to the States, either you go by plane or you go by boat. If you go by plane, it's a lot of fuel. If you go by boat, it's a lot of time. So it changed also the way the industry can work.
So many exciting avenues that it can go.
I agree. I'm not getting bored at work, I can tell you.
That's what everyone wants out of their job, is to be able to constantly be learning and to not get bored.
Yeah, agreed.
Well, Laurent, thank you so much for joining us today here on Future Tech Podcast and sharing a little bit of your insight into ESA and all the exciting new possibilities that are on our horizon.
You're very welcome. It has been a pleasure to discuss with you, Juliette.
That was Laurent Pambaguian, and he is with ESA. You can check out more about ESA at esa.int. Thank you so much for joining us here today on Future Tech Podcast. This has been Juliette Lamar. I'll catch you later.
Coming to Dallas, Texas, September 14th, 15th, and 16th, 2018. The Blockchain and Future Tech Expo. This is going to be a gigantic conference of over 5,000 people. We're going to be talking about blockchain and its applications. We're going to be talking about quantum computing, cybersecurity, artificial intelligence, and several other future technologies that are poised to and actually changing our lives as we speak. Here's why you should attend. As you may know, early adopters are the ones that investigated and profited from things like the gold rush in the 1800s, from the dot-com boom in the 1990s, from the internet boom in 2005, from the smartphone explosion in 2007, from the real estate boom that ended in 2008, and of course, from the Bitcoin boom that started in 2012. Early adopters act now. They don't wait till later. They go out west first. In their covered wagons, they find the biggest gold nuggets. If you consider yourself an early adopter and you want to find the biggest nuggets, then you owe it to yourself to attend this upcoming conference. Blockchain is going to affect how we control and store our medical data, how we send money around the world, how we bank, and more. But artificial intelligence, quantum computing, and cybersecurity will play a pivotal role in our lives as well. And that's why our next event, September 14th to the 16th at the Dallas Convention Center, is going to have not only 5,000 plus attendees, but will showcase blockchain, AI, cybersecurity, quantum computing, and more. You want to get in on the coming gold rush of future tech and opportunity as an early adopter. Don't be left out. To register, go to bftexpo.com. That's blockchainfuturetechexpo.com. Thank you. You have been listening to Almost Here, Around the Corner Future Technology podcast with Richard Jacobs. Subscribe to this podcast, post a review to discover more future technologies that are poised to transform our lives for better or worse, such as Bitcoin, artificial intelligence, 3D printing, blockchain, virtual reality, and more.